Okay, sure. Find a third degree Taylor polynomial for natural log of x centered at.
Hey, no, stop. Wait.
What did he just do?
Took my phone.
Oh, jeez. Okay, so let's do this first. Find third. Okay, so if f of 1 is is 0. F prime of 1 will be 1 over 1. Okay, so the first derivative would be 1 over x, so the next negative 1 over x squared, or negative 1. So if it's, no, it's going to be 2x to the negative 3.
Don't we need that? We're going to need that.
So 2.
Aren't we going to need that?
Yeah, and now I'm going to go to the fourth derivative because we're going to talk about accuracy. But so this one was 2x to the negative 3, so it'll be negative 6x to the negative 4. Okay, so let's do the Taylor polynomial first. Okay, so starting off with 0, and then plus 1 times x minus 1 minus 1 times x minus 1 squared over 2 factorial plus 2 times x minus 1 to the third over 3 factorial. Okay. Just wanted to write it out like that because. But what's 3 factorial? 3 times 2. So I canceled out the 2's. So you can actually kind of see a pattern.
Yeah.
Okay. Now, here's what we want to do. We want to approximate natural log of 1.1 using. Okay.
0.00.
So it's going to be 0.1 minus 0.1 squared over 2 plus 0.1 cubed over 3.
So 0.1.
It's okay, I'll just tell you what it is.
0.001 over 2.
Maybe
plus 0.0001.
0.00095.
Okay.
Where are they going?
Oh my god.
All right, so now we want to see. So that's our approximation for approximating natural log of 1.1 with a third order polynomial. Okay, now we want to see what's our error bound. Okay, so I want R3 of x. Okay, so first of all, the formula. Since we used a third degree polynomial, then we want the fourth at some value of z, x minus 1 to the fourth over 4 factorial. And remember, we always want to just make that positive. It will be positive because we've got to the fourth power.
This is only if you're finding the accuracy.
This is finding how much off they are.
This is the most that the answer could be off.
Yeah.
Not the least, that wouldn't make sense. This is the most that it's off. Okay, so now this value of z has to be somewhere between a and x.
How far are you on breaking back?
What's that?
How far are you on breaking back?
Where am I? All I know is I fell asleep and my husband watched like 2 more episodes and then he spoiled them all for me the next day. He said the girlfriend died and I was like, she overdosed.
Yep.
He's like, oh, not much happened. And then he started telling me what happened. I was like, that's a lot that happened. I don't know, but.
You know, Mr. Harris watched all of it, including Better Call Saul.
Really?
My dad loves Better Call Saul.
That's insane.
Yeah, my dad watched all of it.
Okay.
They're the lawyer, yeah.
So, here's what we want to think about. Usually we're going to pick A or X. It can be something else in the middle. When we did the one before, it was sine.
What's the biggest possible?
So sine the biggest possible is 1. But now we want to think in terms of the fourth derivative. What do we want to make sure?
It's going to be the biggest number. So if you put 1 in there, 1 to the fourth is smaller than 1 to the 1 to the fourth.
Right. So we're going to
So
choose.
that's the biggest possible number is by using the smallest possible x.
Because it's in the denominator, right. So we want to choose that. So that's going to be -6 over 1 to the fourth, and then it's going to be 0.1 to the fourth over 4 factorial. Absolute value of that. These numbers are going to get really small, so if you want to write in scientific notation, that's fine.
I refuse to use that. Yeah, I hate it.
That's totally fine.
I hate it. 8th grade ruined that for me.
Okay. So 1, 2, 3, 4 zeros, 2, 5. So this tells us how accurate our approximation was. Very close. Of course, if we went to a fourth order polynomial, this number will get even smaller, right? Fifth order, even smaller. Well, the idea is, and that's why I wanted to show you that video, that you only need to go out to a polynomial of fifth, sixth, right? A fifth. It's going to be so small that it's irrelevant. So even like a 10th order polynomial is going to be a very good approximation. Okay, let's do this one. Okay. So this one is only second degree. Yes.
Sure. So f of 1 equals 1. F prime of 1 is going to equal 1 over 2. -1 over 2.
Remember, that's x to the -2, so it'll be x
-2x to
-2x to the -3.
Since it's 1, so it'll be -2. 1 over -2.
Good.
Right?
And then
-2.
do another derivative.
F double prime of 1 is going to be 6.
And then another derivative, just because we're going to do the maximum error bound below. The third derivative of x is going to be -24.
That's close. In principle.
I'm just doing this again. We're going to need that for the error bound on
So
the next one.
maximum error bound is the same as Lagrange.
Yes. It's named after Lagrange, but you'll see it on the AP exam as Lagrange or maximum error bound. They're one and the same. Okay, Taylor polynomial. Okay, so 1 minus 2 times x minus 1 plus 6 times x minus 1 squared over 2 factorial.
And just a second degree, so there we go.
Yep, so we're going to stop there. Okay, now I'm not actually approximating anything. This one's going to be phrased a little different. Now I'm saying, okay, what's the maximum error for any values between 0.9 and 1.1?
Oh, I see.
Is that the same as
this to this?
0.9?
Right.
Is that the same as 0.9?
So
to
my
0.1?
center, remember my center is at 1. So how much is it going to be off from a 0.1 to the left and 0.1 to the right of 1? Okay, so R2 of x. So I have to go to the third, and I'm going to put of z. We got to figure out what z I want to choose. And then it's going to be x minus 1 to the third over 3 factorial. Now, z is going to be between 0.9 and 1.1. So I'm thinking about
0.9.
that.
So
What's
0.9
going
is
to make
smallest.
that as large as possible?
1.1 will make it. No, 0.9 will make it as possible.
This one.
0.9.
Why am I having a hard time?
I know, because
0.9.
if it's less than 1, this will make this
Plus 1.
less small. I know, but well,
But then it makes.
my point is, well, this if I put in something less than 1, this
It'll
will
get
get smaller and smaller, which will make that bigger and bigger.
Right.
And anything
But it's
bigger than
negative, so-
1 is going to make this
So
bigger.
But it's
make
negative,
1
so it
1 is
actually
negative.
makes it
But
smaller.
we're putting it in absolute value.
Yeah, so it's gonna be not. Why not? Like I said. Jonah,
So,
I'm the expert here.
so this is what we want to choose.
I'm being bullied. Jonah
So-
cyberbullies me. Max is gonna hear all of this. This is evidence.
I don't. We'll see.
I don't think the mic even picks up.
Max, if this picks up, you can text me when you're watching it.
Okay. There we go. So the most that this could possibly be off is 0.0006.
So it's 0.00677.
Dude, you're not.
I got it. That's a lot, actually.
Well, this
There's
was
only a
only.
second. Wait, the next one will be. My guess is the next one is gonna be.
It's gonna be even closer.
0.00437.
But if
Yeah.
they're actually building something in real life with this,
Uh-huh.
wouldn't it be safe to just go to like the 100? I mean, we have
Sure.
a calculator, so why not?
I'm sure they do. Okay.
Another
Approximate
one.
f of 2.5 using a Taylor polynomial of degree 1. Of degree 1 really means
Just so it won't work out. So 1 plus. F.
tangent line. Okay, so
Ooh, okay, so you got 8 plus 5 times x minus a.
which is, but 2 is where it's centered, right?
Two.
Okay, so now we want to approximate. So f of 2.5, we're going to approximate that by plugging in 2.5 here.
A plus 5 times 0.5, which is going to be point. So it's going to be 2.5,
Plus 8 is
10.25, 10.5.
10.5. Okay. Now we want to see how far off are we on that approximation.
And we've got f double prime of 2 is less than.
Right, so my remainder,
Oh, here we go, ready? It's going to be of 3. So Z is
So
3
we want-
because it's the biggest possible number it could be. So it's going to be f double
right,
prime
so
of.
since they basically gave us, this, by the way, this, you would often see it written like this on like a FRQ. So,
Yes, when you take the exam.
Dude,
okay, I know you're not, okay, stop it.
I'm gonna take the exam.
Stop it, I saw that.
You didn't see anything.
You're not even gonna take the AP exam?
I'm not.
Wow.
You know why?
Why?
I don't feel like it.
You're just.
I'm what, Jonah? He's about to verbally insult me right now.
Oh, no.
That's a
Um,
huge error.
Well,
Yeah, that-
think about it. This was just a tangent line.
If that was a bridge, people would die.
People would die, but that's why they don't just do tangent line approximation.
Which bridge
right?
is this? Just so I can
Dude.
Avoid it.
tell Jonah.
It's the one that
I'm
fell
busy.
down.
London Bridge?
Well, they're British. It makes sense.
Okay,
British, innit?
It's cheap.
last one.
Dude.
Then you have homework time.
I don't
Come
get
on, all right,
showed
don't
up
waste
in my
homework time.
math class.
Okay, f of x. So we have cosine of 2x plus pi over 6.
I don't like this. Just wanted to be that.
Nothing not to like. P of x is a third degree polynomial centered at 0. That's a good thing. Centered at 0 makes it easier.
Ooh.
Use the Lagrange error bound to show f of 1/3 minus p of 1/3 is less than 1/100.
Ooh.
Okay, just quick. Here. Go back to here. Remember how I said, here's your exact value f of x? You got your approximate plus your remainder. So they're basically saying take the difference of the actual and the polynomial, and that's going to be your error. So we're basically showing that the error, the maximum error, has to be less than 1/100th.
Oh, I see.
Right? So we got to show that this is the.
So I know.
Oh,
like-
so they're just trying
Johnny
to trick
can do
us. They're saying the same thing, but they do.
So Jonah.
What do we need?
Jonah. You can-
Third degree.
Third.
So I need to go to the fourth.
Oh yeah, really fourth. Yeah.
So let's just I don't actually need to know. So this will be -2 sine 2x plus pi over 6. What's the
What is
second?
-2? Oh, yeah.
And then the next one will be -4 cosine of 2x plus pi over 6. I don't actually have to plug anything in because all I need to get is my fourth derivative. Third is going to be 8 sine 2x plus pi over 6. And 16 cosine. Okay, now all of this, what's the maximum that cosine could be? 1. So just keep that in mind. All right, so
wouldn't it be 16? Because
it will be. So, because I want this, and then what am I? It's centered at 0, so it's basically 1/3 minus 0, so just 1/3 to the 4th over 4 factorial. Does that make sense? Our x is 1/3, a is 0. Yeah, so this has to be 16.
Where did 100 come from?
Oh, we want to prove, is this less than 1/100th? Is it?
wait.
Well, let's see, 16 times, what's 1/3 to the 4th? So that'll be 180.
It's over 24. Hey, why is it over 81? The 81 comes.
Oh, never mind. It is.
Okay, 1/3 to the 4th? 1/3 times 1/3, right? Or 1 to the 4th over 3 to the 4th? So 16 over 81, and 4 factorial is 4 times 3 times 2. So, is this less than 1/100th?
Cross out 16 and 24.
Okay, so what goes in? 8? 8 goes in 2 times?
Yeah, it is less than.
Yeah, so definitely less than.
It's
It's like
over
over
like
23.
243.
243, yeah. Like, right here it says it's like 243. See?
There you go.
What?
Done.
That's 243.